Okay, so let's talk about recognizing misleading graphs. So I have two graphs here, and sometimes, especially when you're reading like data in newspapers or online or in magazines, whoever's writing an article or publishing a graph, they might do it in a way to make a point that they are trying to make. And what I mean by that is they might use a graph that's misleading. So if we look at these two graphs, they actually show the exact same data. But at a first glance, we see our title is busiest U.S. airports. At a first glance, looking at the first one, what would you tell me about which U.S. airport is the busiest? Well, you'd say Atlanta is the busiest airport, right? Because it has the highest graph. And if I asked you about how much, if we're just looking at this graph, and I said about how much busier is the airport in Atlanta than the one in Los Angeles, then you could look and say, it's like almost 5 times as busy because this bar is way smaller than this bar. So just by going by the heights of the bars, Atlanta appears to be way, way busier than Los Angeles. But there's actually a problem with this graph. Notice the y-axis. The y-axis starts at 55 million passengers. So if we look at a more evenly spaced graph, which starts the passenger number at 0, and we look here, we can see that yes, Atlanta is still the busiest airport. That is a fact. But is it 5 times busier than Los Angeles? No, it's like a fifth, 1/5 busier than Los Angeles. It's a lot less, it's a lot smaller of a difference than this one. So you have to pay attention to graphs and make sure that their scale is starting at 0, and really read graphs critically to see whether they are portraying the data accurately. Okay, and so that's one way that they will make graphs misleading. Another way is they might use a break in the data, and I'm just going to show you an example here. I have this graph here, and just at a glance, you would say like sports fan is like about what, like 1, 2, 3, 4, 5, maybe 6 times more popular than Music Cubed. That's a lot more by the Sports Fan magazine than Music Cubed. It's like 8 times higher. However, if we more closely, examine the data, we see that because of this break here, this is showing us that they had a break in the data. See, each of these segments is 1, right? They each go up by 1. But this one right here goes all the way from 0 to 8. And so really, if I put a number here, music, there's about 8 million issues. Sports fan, there's about 16 million issues. So it is more, but it's only about twice as much. It's not 8 times as much. And so you really want to watch out for these breaks to see if they are taking out data that should be included. Because in this case, we should be including all that data up from 0 to the 8 mark. So we really should have a lot more lines. And so we could redraw this graph, and there should be 8 spaces here. It should be way spread out so that we can see a clearer picture of how the data is distributed here. Now, a break isn't always a bad thing. So I want to show you an example of when a break is a good thing. Okay, so I have 2 more graphs here. And just give me a moment to tape them onto my paper. These are projected U.S. college enrollment. And while I'm taping, you can notice that one of them does use a break. The other doesn't. But in this case, the break is a good thing, and I'll explain to you why it is, okay? So if we look here, let me zoom in on them a little bit. There we go. All right, so if we look here, in 2007, the projected enrollment is between 15 and 20. So in this case, there are no numbers, there are no dots from like 0 to 15. So we don't really need those numbers there. Because in this case, does this really help us to see how college enrollment is changing over time? Because we're trying to see change over time. But this doesn't really help us to see because the scale is so small. It's going up by, or the scale is so large rather. It's going up by 5s that it's very difficult to see how what the change is going to look like in college enrollment. Now this graph, they spread it out. They did use a break here, but in this case the break is a good thing because it's not causing us to take away necessary data. What it is doing is it's taking out numbers that we do not need, because since 2007 there was projected to be 17 million students enrolled. There's really no need to have numbers below that, okay? And so with this graph, it's the exact same data, but since we have a smaller scale here, we're only going up by 500,000 in each interval. Since we're only going up by 500,000, it allows us to see more clearly how the data is changing over time. So breaks are a good thing as long as they're not going to cause you to mislead your reader. As long as they're not going to make the data look different than what the reality is. So your task today in your assignment will be to analyze graphs and decide whether or not they are misleading. And if they are misleading, give an explanation for why they are misleading.